Hey there, web developer. Interested in getting started with Cloud Firestore, the hot new database in the cloud for mobile and web apps? Well, that's a good decision. I always knew you were the smart one. So let's start saving our data to the cloud on this episode of Firecasts. So here's the deal. I want to create a little web app where we can help keep track of one of life's eternal questions. Is a hot dog a sandwich? More importantly, I want to save this information to the cloud so I can look up the current hot dog status at any point from any web browser. So using my amazing HTML skills, I have created this web page consisting of a text field where we can record the latest hot dog as a sandwich status. Then next to it, I've got a save button where we can save this information to the cloud, and a big old H1 tag at the top where we can display our latest hot dog status info. Now later, we'll load whatever data our user has saved to the cloud and display it in the header tag at the top. If you want to follow along, go ahead and create your own version of this index.html file. It really is nothing more than these three elements. In fact, let's take a closer look at what I've got set up. So here's my index.html page where I've got all my elements created, and up here I'm loading the Firebase library. Then over here's my app.js file where I'm configuring my Firebase project with the values that I got from the Firebase console. Actually, before I do anything else, I'm going to go ahead and include the Firestore component like so. Obviously, these exact URLs will be a little different than what you're supposed to use, so do make sure you check out our docs for the actual correct version. And if you don't know what I'm talking about here, go ahead and follow our Getting Started video for the web. The link is in the description below and probably in one of those fancy YouTube info cards. And then come on back. It's okay. I'll wait. Now, before we go ahead and write some data, let's take a moment to understand how Cloud Firestore data generally works. Frankly, this could be the subject of its own separate video, and it probably will be one day. But here is the executive summary. Cloud Firestore is a document database. That means it kind of stores your data in a big tree-like structure, a bit like the original real-time database, but everything is placed into documents and collections. You can think of a document as something like a JavaScript object. It's got like key value pairs, which we like to refer to as fields. And the values of these fields can be any number of things, from strings to numbers to binary values to little JSON-y looking objects that the team likes to call maps. And collections are basically, well, collections of documents. So there are a few rules around the use of these things. The first is that collections can only contain documents, nothing else. No collections of strings or binary blobs or anything else here. Second is that documents can't contain other documents, but they can point to subcollections. So it's very common to see a collection containing a bunch of documents, which then point to subcollections that contain other documents and so on. In a workout app, for instance, I might have a user's collection, and this collection would contain a document for each user. And then each of these documents might point to like a workout subcollection that in turn contains a document for each different type of workout that the user has performed. And these might then contain a history subcollection that keeps track of every time the user has performed one of these workouts along with like their average heart rate or other data. Now, if you're coming from the real-time database land, this kind of deep nesting might be giving you heart palpitations. But don't worry, this kind of data structure is completely normal in the Cloud Firestore world where queries are shallow. Meaning that when you grab data from a document, you'll grab just that document and not any of the documents contained in any of these subcollections, which is nice. The third rule is that the root of your database can only consist of collections. In a normal production app, this is going to feel pretty natural. You'll have like your collection of items and your collection of users and your collection of games or what have you. The one time it's going to seem a little awkward is when you're creating a little test app like ours and you want to save like one string. So looking at our app, I think the top level is going to start with a collection that I'm calling samples. This will then contain one single document called sandwich data. And this document will itself have one key value pair or field called hot dog status. Make sense? All right, let's start building. So if we jump back into my HTML page, you can see that I've already created IDs for my header, my text field, and my button. So first things first, I'm going to jump into my app.js file and create a few variables to hold references to these elements. And I'll do that just by calling query selector. I'll do the same for my text field and my save button. And we're done. Okay, next up, I'm going to create a click event listener for the save button. Now I'll grab the text that I want to save from my input text field.value, and let's log it to confirm we have some actual data. Now I just need to save it to the cloud, and to do that I need to specify in which document I want to put this data. And we do that through something known as a document reference. Now it turns out I'll be using the same reference a few times throughout this project, so I'm actually going to define it up here at the top of the script. Actually, first let me just grab a reference to Firestore. And now there are a few ways of setting my document reference. I could call firestore.collection_samples.doc sandwich data. Now, I kind of like doing this because it serves as a nice reminder that you're always going to be alternating between collections and documents, but it does start to look a little silly when you get several layers deep. So an alternative that I sometimes like is calling firestore.doc and then entering the full path directly here. In our case, the path would be samples/sandwich data. Just again, remember that in your path, you're always going to be alternating between collections, documents, and so on. So now that I've specified my document, let's go back to my event listener where I'm going to call set on this document reference. Now this will take in a JavaScript object to represent the data that we want to save for this document. So we'll set hotdog status as text to save, and well, that's all I really need. This will replace my current document if it exists, and it will create it if it doesn't. It also conveniently creates the samples collection too, so I don't need to worry about whether or not that exists. Now this set function, as with most Firestore functions, returns a promise, which means it's pretty easy to note when this call is complete. So I'll attach a then callback at the end here and print out a little success message. And come to think of it, I'll add a catch here to print out any errors. And we're done. Time to load up our page and give this a try. Oh, whoops. Okay, wait, let's fix that little semicolon. Okay, now let's give this a try. So here I'm going to enter not a sandwich as the current hotdog status, because it's not. I'll hit save and, whoops, looks like I'm getting an authorization error. And this is because, just like the real-time database, my Cloud Firestore implementation contains a set of security rules that determine whether or not a certain action is permitted. And at the time of this video, by default, they are set up so that nobody can read or write to the database. So the proper solution here would probably be to add some sign-in using Firebase Auth and then create some proper, well-thought-out security rules based on what information I'm willing to share to each individual user. That said, all that would make this a much longer video than it already is, so I'm going to kind of do a bit of a hack here and make anything in my samples collection open to the public. So let's head on over to the Firebase console, make sure I've got my project selected and I'm in the database section. And then here I'll make sure Cloud Firestore is selected from my list of database options. And then I will click on the Rules tab. And I'm going to add this here to allow reading and writing to anything that's part of my samples collection. Now this is a pretty terrible idea from a security perspective, but at least I've contained the damage to just what's in my sample collection. So I'll publish that and we're done. Okay, I'm going to wait a minute or two, then give it another try. I'm going to go back into my app, hit save, and yeah, looks like it works. And I can verify this by going back to the Firebase console. We'll select the Data tab to view our data. We'll select our samples collection, and yeah, sure enough, looks like we've saved our hotdog status to the world. Woohoo! And while it's great that we can see this data in the Firebase console, we need to show this important information to our users too. So next up, let's learn how to grab this data from the cloud and put it into our H1 tag. Now, like the real-time database, Cloud Firestore lets me listen to changes in the database and update my app in real time. However, I know that for some of you out there, the idea of creating a real-time listener for all your data is weird and strange, and sometimes you just want a basic fetch call to get your data, right? So I'm going to show you how to do that first, and then we can talk about getting fancy with our real-time listeners. So let's create a load button. I'm going to give it an ID tag here, and then in my app.js file, I will save that to a variable, and we will define its event listener. Now, getting this function to work is actually quite easy. I'm going to take that same document reference we created earlier, and instead of calling set on it, I'm just going to call get instead. This returns a promise, so I can attach a then callback to it, which will run when this get call is complete. Note that this takes in a document snapshot that I'm just calling doc here. A document snapshot is basically an object that represents your document. You can find out its ID, read some metadata about it, make sure the underlying document it represents really exists, and more importantly, grab the data that it contains by calling data on it. So we'll see if this snapshot exists, and if it does, we will call data to extract the contents of that document as an object. And then I can set the text of our big output header to mydata.hotdogStatus. And as long as we're here, let's add a catch at the end to catch any errors that might come up. So let's run this, and there we go. I can still save our latest hotdog status to the world. It's still not a sandwich. And we can see in the console that this was saved. Now I'll click the load button to load it, and there it is on our page. Hey, that's nice. So this is great. We've got our data successfully saved and loaded from Cloud Firestore. But what if you are interested in getting your data in real time? What if this explicit fetching seems quaint and old-fashioned to you? Well, let's show you how to get your data in real time as well. Basically, the process is going to work nearly the same. Let's create a function called getRealTimeUpdates. And in there, I'm going to bring up my doc ref. But then instead of calling get, I'm going to use the onSnapshot event listener. This will fire the first time I call it, but then it will also fire anytime thereafter when my data changes. Now this call takes in a callback function which accepts the document snapshot as an argument, essentially just like my get call. So in fact, I'm just going to copy the exact same code from my get call into here to update my label, and well, that's it. We'll call get real-time updates at the bottom of our script, and that should be all we need. Here, let's reload the page. Now you can see that thanks to my onSnapshot listener, my text automatically gets updated with still not a sandwich, the value that was in the cloud previously. So let me change my status to potentially a sandwich. I'll hit save, and you can see that my label gets updated automatically without my having to even touch that load button. Neat. Wow, that was fast. In fact, maybe too fast, right? It looks like my label got updated before that data was even saved. How'd that happen? Well, what's happening is that Cloud Firestore is making my app run as speedy as possible by notifying me of changes that happen locally as if they had happened on the server. But in the meantime, it's still going ahead and updating that data remotely in the background. Now, if you want, you can also get notified by the SDK when the write actually happens on the server. You can look in the documentation for the include metadata changes option, but by default, the SDK will ignore the second event because it's essentially a duplicate of the first. And in fact, with a little printf debugging, or I guess console log debugging for you web folks, we can see this. Here, let me log my data to the console in my onSnapshot listener. Now let's reload the page and take a look at this object that gets returned in my console. Here's the initial value that we loaded from the cloud. And let's expand this data object here. We can see that it has a metadata property, and by expanding that, we can see we have this value, pending writes, which is currently set to false, meaning basically that it came from our server. So now let's save our data. Let me write more like a modified taco, potentially offending millions of taco lovers, sorry. Now when I save it, the object that gets returned in my onSnapshot listener has pending write set to true, meaning that this is the local version of the data in my database that's waiting to be written. Now if you wanted, you could have this event fire even when just that little bit of metadata changes, and that's something you could add in your listener like so. And you can see that when I make an update now, my onSnapshot event fires twice, once for the local update and once again when the server comes back with that same update. Now there may be times when this behavior is what you want, but honestly most of the time the default behavior works just fine, so I'm going to go back to that. And there you go. Congratulations, you are now saving your data in one of the most powerful and sophisticated online databases in the world and using it to store whether or not a hot dog is a sandwich, thereby resolving what might be one of the greatest controversies on the internet, until next month when something else pops up. Now there's a lot more to learn about Cloud Firestore, including more details on how that data is structured, how subcollections work, and how to run some more sophisticated queries, all of which are great topics for future videos. In the meantime, set your security rules to something a little more sane. Be sure to check out the documentation and try using Cloud Firestore in your own app. And I will see you soon on another exciting episode of Firecasts.